This is a story about making do in your shed at home so that you can make the kinds of things that you need to make without blowing the budget or engaging in fantasy workshop syndrome, okay? So when I built this version of the Fat Cave, I'd always wanted a proper fixturing welding table, like aerospace flat, nitrided cast iron surface with CNC machined 16mm holes on a grid that's 50mm between centers, and just, I love that shit. Like, I'm only human, dude. The only problem with that, actually there were 6,000 to 8,000 problems with that, I note, and it was the cost. Like, it's going to cost me 6 to 8 grand for a welding table like that, roughly as big as this scrap steel you see before you bolted together. Finally, today. So this is 950 by 1550. If you're not from around here, it's ballpark 3 and a bit feet by 5 and a bit feet, I think. So you could weld up most things that you would build in your shed on this. And the other thing about it, of course, is that a lot of things are kind of symmetrical and you only have to work on one half at a time. So I can go out that way as far as I need to go and still use this surface for the fixturing and the welding and stuff like that. Now, I am ashamed to admit to you that for the past, I don't know, 18 months or 2 years, these bits of metal have just been sitting on these glorified sawhorses and clamped together with like F-clamps. That's kind of embarrassing, but I had to unplug because the journalism sewer is not a place where you can live 24/7 no matter how hard one tries. So I just had to do something worthwhile and a bit visceral and more hands-on today, and I thought that this might be an opportunity to talk you through some of that and get you a little bit further down that track to becoming the madman of metal manipulating mayhem you've always perhaps wanted to be, especially if you're sort of half handy with a drop saw and a drill driver and a piece of timber, because there's a lot of crossover in all of that skill set, although there are a few slight differences as well. What I've done is I've made this table out of scrap metal, and the total cost less than 200 bucks, right? Which is a lot better in many ways than an aerospace flat thing that I'm going to build the same stuff on for 8 grand, okay? And hey, if I ever did want a precision flat surface, or if you ever want to turn any surface, even the garage floor, into a precision flat surface, here's how you do it. This is hack number 1. You get 3 bits of metal. It doesn't have to be these 3 bits, it's just 3 bits of metal. There's your precision flat surface, because 3 points define a plane, dude. That's why you can carry a plate on 3 fingers but not 2 or 1, right? 3 points define a plane. A plane is a flat surface. This is a flat surface between here and here and here and here and here and here. So it does seem a little over the top to drop 8 grand on a more fancy version of exactly the same thing when you don't really need it that often. And when you do, it's only 3 little chunks of metal away, isn't it? Like, you could do this with 3 relatively large nuts or bolts or anything. It can be anything. You could get 3 of these 1, 2, 3 blocks. We'll get to this in just a minute. That's another hack just there, incidentally. So what I did today was, instead of this shameful clamping arrangement that had pertained for the past several months to years, I actually bolted it together. So I got these bolts. These are class 10.9 M16 bolts. They're flange-headed bolts, as you can probably see there. Class 10.9 is the middle version of high tensile. Got a couple of matching galvanized washers and a matching high tensile nut. And that's what holds this whole thing together now. 3 over here, 4 in this one, 4 in this one, and 4 in this one. So a total of 15 fasteners, total of 30 holes, and amazingly enough, when you torque one of these up, the clamping force is about 8 tons. So 4 fasteners, 8 times 4, 32, let's call it 30 tons worth of clamping force with 4 fasteners. And the other reason I bolted it and didn't weld it together was adjustment down the track if necessary. I can also break it down if I need to move it much more easily, and I can tweak its position anytime I want, including during assembly, whereas once you start welding, it's kind of forever, or there's a hell of a lot of grinding if you need to do all of those things. So I didn't really want to weld it together, I wanted to bolt it together. And I know that for a lot of people, they would find that terrifying, because here's the channel we're talking about. It's 250 between the thumbs, and it's 90 between thumb and forefinger here. The thickness of the flange is 15 and the thickness of the web is 8. And I've got to drill 30 holes essentially in that. And it just drilled like butter, and it was a piece of cake. So I want to talk to you about how to do that, what you need to do that, and not just the gear, but the underlying technique that means the holes are all going to line up when you've got it done. Kind of important with metal, because with wood, there's a lot more, I guess you'd call it malleability. It's amenable to being nudged around a lot more than metal is. It tends to be a bigger deal with any sort of metalwork project if the holes don't line up. There's no real precise measurements with any of it. I didn't bother with any of that. I just kind of arbitrarily worked it out. So what I was pretty careful to do though was to mark out the first set of holes in whatever piece of steel. And then I needed to transfer them to the other side. I used this little jig here. Now, if you don't have any 1, 2, 3 blocks, you need to get yourself some of them, because these things are absolutely brilliant. Like individually, they're brilliant. They're precision ground hardened surfaces, 1 inch by 2 inches by 3 inches. You can bolt them together with your little clamping kit. Everyone says, why have you got so many clamping kits and why have you got all of that stuff? Well, this is 8 millimeters, 12 millimeters and 16 millimeters, and everything in them is just so useful. It's a shim. It can be used to bolt your 1, 2, 3 blocks together with some of the studs and some of the nuts, and then you get a jig that you can use to mark out the depth of the holes based on the height of this surface. You can go down to the edge of your 1, 2, 3 block here. There's a precision flat square surface to mark out the depth of the hole. And as long as you transfer the sort of longitudinal location of the holes with your trusty speed square, then that's all you need to get the holes to line up. Because once you've got them in the right position this way, and once you've got them in the right position that way, they don't have any alternative but to line up. Now, the thing about drilling such thick steel, I don't actually think 15's that thick, but to a lot of people, like if you've only got one of these at home, it's thick, okay? It really is. But you just have to upgrade to a slightly different drilling machine, and you can drill this stuff like butter. Now, this is a Vevor magnetic drill, okay? And it uses a thing called a welding shank. And what goes in the welding shank is one of these babies, which is an annular cutter, and it's got a pin in the center of it as well. And the pin does two things. It helps to locate the center, which you mark with your trusty center punch. So the pin locates the center, and then when the annular cutter gets through that steel, the pin is spring loaded, so it punches out the wad of steel that remains. This is really just a precision ground hole saw out of high-speed steel. They're absolutely brilliant to use. The quality of the hole is really good. The only thing you've got to be careful about is you've got to feed it a bit of coolant. Now, drills of this nature typically come with tanks that you can load up so that they'll drip feed coolant through the shank and through the bit into the cut. That's cool, literally, but I prefer to do it manually because I find the tank a bit cumbersome, and sometimes you're working in an environment where the space is enclosed and it's a pain in the ass to pull it all apart if it doesn't fit. So your squirty bottle full of coolant. Now, I know on YouTube there's a lot of people who use oil to do drilling. Now, oil is a lubricant, and the point of a lubricant is to reduce friction. You don't need to reduce friction with a powerful drilling machine like this. What you need to do is you need to keep the high-speed steel cool, because you don't want it to get too hot, because that will interfere with its heat treatment and you'll end up burning the tip out and dulling it. Now, I've drilled these 30 holes today, and this hole saw is still razor sharp. It's like razor. It's, you know, good for hundreds of cuts if you just treat it a little bit carefully. Now, I've used this machine for some other jobs as well, and the beauty of this, right, is that if you go to some hardcore engineering industrial shop and you buy a mag drill, it's going to cost you many times more than this drill will cost you, all right? So that's up front, it's going to cost you more, but then you're going to need a set of annular cutters, or at least the one to do the job. Whereas this baby comes with a set of standard annular cutters, metric in this case. They go from like 12 to 27 millimeters. There's about a dozen of them, I forget what number, but essentially if you went out and just bought that set of annular cutters, it would cost more than this drill and the annular cutters. So for home use, this is the deal of the century. And these things are almost better than a pedestal drill press, right? Because a pedestal drill press is really good if you're working on sort of small jobs about this big or maybe slightly bigger. You can clamp them in the vise and drill very precisely and line it up. And you can also productionize your workflow a bit if you use the vise bolted to the table as a kind of reference surface. Then you won't have to mark out if you're doing 100 different things that all have to have exactly the same hole in the same location. You can just do it like process work because you've got your reference surfaces. But when you've got a mag drill, you don't have to get a dirty big piece of steel and figure out how to lift it up and carry it to your drill press and support the other end and just drill a few holes, right? You just slide the drill press around, and it's got a really strong magnet on the base that's got like more than a ton of clamping force. So once it's magnetized, it's not coming apart. And then you've got your annular cutter, you spray it with a bit of coolant to keep it cool. You've got this rack and pinion to drive the whole system, and it works really well. Now, full disclosure, Vevor did give me this drill press, this magnetic drill, but I didn't really need it. I've already got another 4 of them, including the predecessor of theirs, which I bought with my own money. And they just said, hey, test this. So I did the other day, and then I thought this is actually really nice because it's kind of lighter than the full heavy-duty industrial unit, so easier to move around, and also a bit narrower, and it's just generally more mobile. So these 30 holes, like butter, turned what would otherwise be an insurmountable opportunity into a piece of cake. I'll have a link in the description for all of that if you're interested. If you're wondering about the coolant, I just mix it up. I buy this as a concentrate. I get this from Hare and Forbes. It's, I'll try and get the reflection off that. It's just XDP cutting fluid concentrate. You just mix it up in water, and I've got like 25 litres of it over there in a jerry can, and I just decant it into a spray bottle as necessary for these kinds of jobs. And that works really well, and there's no evidence whatsoever of discoloration of any of the annular cutters that I've used so far, and they're still maintaining their edge, so that seems to be working pretty well. The jig thing, we've covered that off. Now, what else can we talk about? Oh yeah, the fasteners. Now, this is kind of interesting, right? Once you've got the fasteners in the right spot, you got to think about torquing them down. So I looked up the torque specification for class 10.9 M16 fasteners. It's 270 Newton meters. Now, I want this to be easy to pull apart into the future, and I also wanted to reduce the manual effort because you're lying on your back and you don't have a great deal of mechanical advantage when you're doing up these centralized bolts in particular. So I elected to go with my Penrite Copper Ease, right? It's just an anti-seize compound, so it's grease with copper flakes in it. Looks kind of cool, and it works really well. And this will probably see me out. You know, I use it a lot and it hardly seems to be diminishing in volume at all. So there's some magic in play. I don't know. The general rule of thumb with torquing these down is 270 Newton meters with a factory finish. But if you use lubrication, you should knock about 30% off. So I went from 270 down to 180. And the official specification from Ajax is about 8 tons worth of clamping force. And if you say to yourself, this one join here between these two flanges is 4 fasteners, so that's 4/8 of 30-ish tons. If the mu of steel on steel, like the coefficient of friction of steel on steel is 0.2, then that's about 6 tons worth of shear load either way to disturb the orientation of this joint. And that's what high tensile fasteners are all about, you know. If you use the proper fasteners, it makes the job really easy and it gives you the result you want. So I did a few things to make this very easy after I drill the holes. And the first thing was, this is a 16mm diameter thread and I used an 18mm diameter annular cutter. So I've got an 18mm hole and 16mm thread, but I've got 2 18mm holes when you think about it. So I've got 2 + 2 worth of clearance in X and Y, which means I've really got 4mm. And if you can't mark your holes out within 4mm, then you need to stop dreaming about being an air traffic controller. You know, every one of these fasteners just slid in. There was absolutely no problem with any of that, you know, just straight through in each case, and I barely measured it. I only ballparked it. I got one set of holes laid out and then I just copied the measurements across. Like I copied the measurements across with a speed square, and then the depth was standardized with my little jig here. I punched it with a center punch. I marked, incidentally, this is really important, I did use a felt tip marker, but only to highlight the areas where the holes were going to go. What I used to actually mark the lines was a carbide tipped scriber. These things are awesome and you need to get one. They're just so much better than the alternative. I see dudes marking out projects in steel, hole locations and things of that nature with felt tip markers. It's nuts. It's not precise enough. You end up with 2 holes that don't line up and you can't get the bolt through. It's a freaking disaster. So don't do that. The other thing is, when you use a steel scribe, like a carbide scriber on steel, it carves a little trench. And then you mark X and Y, there's where your hole's gonna be. You can feel the intersection of the trench with the sharp point on your center punch, right? So it doesn't matter if you're blind as a bat. You just feel it and you go, that's where it is. And you do a quick sanity check and then you nudge it with your hammer. In my case, I'm kind of functionally in love with this brass hammer that I've had for donkey's years. You can see how deformed the faces are from using it all the time. I got these other really nice hammers over here and yet I love this one. I use it all the time. Go figure. A brass hammer is a really lovely thing to use, and you should think about getting one of those, dude, because you won't look back. You really won't. I'd also say from a marking out point of view that, I don't know what you call these actually, but these things are absolutely brilliant for marking offsets in the right location. Like if you want to mark 50mm in, you just set your 50 up, you clamp it up, there's your 50. There, we'll do a hole there, we'll do a hole there. You can also use them for marking welding locations. Like if you want to stitch weld something together, you can go, well, I'm going to weld between here, and it's just going to be that bit, and then I'm going to do this bit, and then I'm going to do that bit, and that defines the length of your weld if you want it to be, you know, a little bit more than an inch long sort of thing. They've even got a vernier scale down on one end, so if you want fractional millimetre accuracy, you can do that by eye. It's absolutely brilliant. So that basically covers off getting the holes in the right places and using the fastener. Obviously use a torque wrench for getting your 180 Newton meters and you just clamp them all up. They're not going anywhere unless you undo it. But at that sort of torque specification, the fasteners are infinitely reusable. They don't yield, there's nothing like that. They're not even close to that, right? So you've got plenty of clamping force and the fasteners are never going to wear out. They're going to be easy to undo because of your anti-seize. So that's brilliant. Now, just another couple of quick points about the mag drill. When you buy this one, not only does it come with a full set of cutters, it also comes with a standard drill chuck, like for a twist drill. It's got a Welding arbor on the blunt end of the chuck. So this is a Welding shank. It's got these two flats. The flats engage with these two grub screws here. You just crank them down with the right Allen key. I think it's a 5mm Allen key. So you can put the chuck in, and you can put your standard twist drill in as well, although you are a little bit clearance limited when you do that. Like the chuck sticks down quite a fair way and you'll probably only get a small diameter stumpy drill bit in there if you want to use it like this. You could take it to the edge of the table and use it over a ledge if you've got a platform lower down. Perhaps that's a project for another day on this surface, but it does tend to be very space efficient compared with, you know, a full drill press, because they do take up rather a lot of space and it's pretty hard to just chuck one in the back of your ute, your full drill press. Whereas you can get one of these and just chuck it in the back of your ute all day long, right? So there's that about it. But they do produce rather a lot of Satan's fingernails, okay? You probably saw all the swarf coming off in the overlay vision to do with this project. And I know you've seen video of me pulling that away from the cutter with my fingers. I'm really careful when I do that, and you might want to do that with needle nose pliers if you know what's good for you. And the other thing that's really good for fishing it up in bulk is one of these babies. These swarf wands are fantastic. Like, you see a bit of offending swarf, you just pick it up like this, and then you take it over to your bucket and turn the magnet off and it all just falls off. If you try picking it up with a vacuum cleaner, it's just going to clog things up all day long, whereas this is a super efficient way of doing that particular job. So, what else? Oh yeah, these things are brilliant. Not the drill, a Ryobi drill. I'm a bit agnostic when it comes to these sort of hand power tools. I got some Milwaukee stuff up there. It's definitely better, but these things get the job done. And on a cost basis, they're just tremendously efficient. What's really cool though are these zero flute countersink cutters. They're just right. You could buy them in a set. This one handles 15 to 20 mil holes, I think. So they're just absolutely brilliant for deburring. You know, you want to deburr the holes so that they don't have ridges on them that mean you're going to get a build-up when you tighten the fasteners together. So you just deburr the holes. It's harder to cut yourself on them, and they go together better like that. And these are just a delight to use compared with every other multi-facet countersink I've ever used. So you can get yourself a set of them. You can drop the hint for Christmas perhaps that Dad would really like a set of these. These things are awesome. The other thing you'll see me using in the video are these glasses. These are Fuglies, F-U-G-L-I-E-S. They're Australian brand. But the real beauty about these, apart from anything else, is that they're bifocal. So, like everyone else my age, I'm having trouble focusing here, right? So if you're having that difficulty focusing here, you can get the +2 cheat lens, like the reading glasses type +2 thing, in the bifocal. But when you look up, you just see normally, right? So when you look down here, you see the +2, and all of a sudden, reading your scales and reading a vernier and all of that sort of stuff, it's perfectly clear. They got the padding here too on the inside, so that if you ever do, one of the problems with safety glasses, right, is that if you ever do get hit in the face properly with something, the glasses can hit around the orbit of your eye and cut you up quite badly, whereas these are padded, so that's pretty clever as well. You just have to do an internet search for them, Fuglies, but I've had these for years. They're really good, and they're not a sponsor, and I have no commercial affiliation with them in any way. Now, the final thing is, how did I go? I had my embarrassing clamped together amalgamation of scrap steel, and now at least it is the one block of surface. I give myself 6 out of 10 for how it went flatness, frankly, because this is pretty flat here. These 3 parts here, right? They're pretty flat. This looks like a ruler, but it's actually a precision instrument. It's like a straight edge, like a proper precision ground metrology type straight edge. I do treat it like crap, but it's still pretty straight. These 3 bits here are nice and straight, and these 2 bits here are nice and straight as well. But unfortunately, there is a valley just here. The valley is like just along this line here, and it's about 2 to 2.5 millimeters deep, and it's doing my head in. So I am actually going to undo these 4 bolts and fix all of that up, but I need to go to a specialist supplier and get some deadly poison to fix that. So if you'd like to know what that is, I could do a video on that and fixing that up down the track, and what deadly poison I can use to fix this all together. It could be quite exciting if I live to tell the tale. Let me know. Anyway, I just wanted to let you know what I did today and show you that, you know, you could save thousands of dollars by doing just the same thing. Go to the local scrap metal dude and have a look for some suitable steel and go, yeah, that looks flat enough. Now, you probably don't have one of these, but just take your ordinary stainless steel ruler and just have a look at the surfaces and see how they go. You know, if they're nice and flat, you're in the running, aren't you? And you're not going to risk too much money anyway, because if it's only $100 on the line and you need to upgrade it later on, no problem. You can hit this with a hammer. You can weld stuff to it. You're not going to do that on your precision metrology type fixturing surface, are you? But if I need to fit a couple of jigs onto here, like I can get little bits of angle and just weld them, tack them to the table here and here and here and here, and there's my 90-degree surface for a particular thing. If I'm making 5 or 6, I'm not going to feel bad about that, because I'm just going to break them off with a pair of pliers later and grind it flat with a flap disc, and no one's ever going to know, including me. I'll probably forget about it down the track. This is one of the real advantages of this kind of system. Now, if you're interested in this, and I don't know how this video will go over, but if you're interested in this, I can show you some future upgrades. I've already got the drilled and tapped holes for the bench grinder, which is actually a sanding disc and a wire wheel and a linishing disc. And it can go that way or that way. I've cross-drilled that. I've got the 4 holes for the vise on a swivel base here and here, so I can move that wherever I need. That means I can use the vise as a vertical fixturing surface. I can rotate the jaws around and rotate the jaws around and hold anything in any angle I want with the jaws, as long as I need to weld it just here. So that's pretty cool. I'm going to drill some holes along here so that I can use this as a jigging surface, so that I can put some shoulder bolts in here and some shoulder bolts in here, or some other kind of fixture, so that if I'm building a gate, I've got a reference 90-degree surface along here. And obviously the purpose of putting the angle on the sides was to give myself a nice solid lip here that I can clamp over with any kind of, you know, G clamp or F clamp, C clamp, whatever it is, I can clamp over that, no problem. It also turns the whole table into the ground for a welding operation, which is really nice if you're moving from here to here and over there and whatever, or you're doing a lot of the same sort of work. You're getting this thing and putting it down here, you can just weld it, right? You don't have to get this thing and put it down here and grab the earth clamp and connect it to the job and take it off and then remove the part and get a new part and put it down here, grab the clamp and put it on repeat. It makes it much easier just to go, bit of a lightsaber, put that away, grab the next one, because it's all energized, baby. If you do that though, got to be really careful about putting pressure pack cans on the surface, because that's grounded too. And the last thing you want to do with your electrode holder is that, because next stop, the burns unit. Don't do that. That's about all I've got for you. I hope I covered everything off here. I just wanted to point out how easy it potentially is for you to have a crack at seemingly ambitious projects in your own fat cave, ones that you might have thought were beyond you. But I've got to say, dude, if I can do it, you can do it. This wasn't that hard. It's a major upgrade. I'm going to cure that valley. These additional holes are going in, and I'm still, I don't know, $5 grand in front.